everyone. In a previous video, we talked about the PID_T with the type def in C programming grammar, right? In this video, we will focus on this source code for our capability as midterm test preparation, alright? As I mentioned many times, in C program language, computer first to try to find the main keywords because main means the beginning part of the given C programming code, right? So computer first to try to find the main keywords and then go to the inside of the source code. When the computer meets the first line of the C main keywords, it can find the PID_T data type with the PID variable, right? So computer allocates a specific memory with the name PID, and computer try to store the assigned integer value with PID_T data someday, right? And then go to the next line, and computer try to recognize the right part first when the computer meets the equal reserved word. So computer should try to understand the right part. The right is the capital F fork function, right? So computer cannot understand the capital F fork function because computer only knows the lowercase f fork function as a standard system function, right? So computer try to find capital F fork function in this code. So go to the top line for finding capital F fork function. But the first function of the user defined in this code, Unix error, and go to the second function. So computer can find capital F fork user defined function, right? So, and then computer can understand the meaning of the capital F fork function whenever it meets the user-defined function in this source code. So when the computer go to the first line of the capital F fork function, PID_T with the PID variable. So even though the PID variables are same inside of the main and capital F function, as you will run the local variable concept in Python or R, these are separated local temporal variable, right? So you don't need to worry about the redundant PID because each PID space is separated in a specific user or main function, right? So computer go to the second line, and computer also try to understand the right part when it meet the equal, right? So computer can meet the lowercase f fork function. The computer already knows the meaning of the lowercase f fork function because it is related with the system programming function, right? So as I already uploaded the definition of the lowercase f fork function in the next slides, lowercase f fork function can create a child process, alright? So if you compare this source code with this figure, you can imagine the meaning of the fork function. Please compare fork function with this figure. When the computer meets the lowercase f fork function, it can create child process, alright? So child process can simultaneously execute the redundant copied this code in the separate memory space. Alright? So for the first time, I will show the helpful figure. So if parent source code called the fork function, parent has its own source code in a past memory place, and child was created with the same code in a separated, the copies the same code in a separated other space of the memory. Alright, so two processes can be simultaneously executed. Alright, so it is very helpful figure for understanding of the meaning of the lowercase f fork function. Alright, so go to the original source code. So the parent can execute its own part with the printf source code, right? Simultaneously, in the another copies the same codes, child process also executes the printf function after the fork function. Alright, so each process can exit its own original and copied codes. Alright, so when you compare the original source code with the execution resulting on the screen, the parent process prints 516 with the process ID, right? For expressing each recognizable the child process ID. However, in the child process, return the print the 0 for expressing the child process ID. Alright, so 0 was printed in a child process. Alright, so we will cover the number of the usage of the fork functions together in the next slides. So you should understand the meaning of the lowercase fork function according to the numbers of the calling of the lowercase fork functions. It is a little complicated, so you should follow it step by step. Okay. How about the Unix underbar adder user-defined function? Sometimes after lowercase f fork function, even though the successful process ID can be defined or allocated with the positive values, but if PID value is the smaller than 0, such as the minus or negative values, the system should make the system errors for exceptional that is related with the 8th chapter, right? Exceptional and the control flow, like that. So Unix error function can be called it with the user defined and the original the standard error functions. The str error was defined in the error.h file, so you don't need to check the error.h file, but if you are interested in, you can find it similar to the types.h files. All right, so with the types of the error, we can express the error content with the %s, the grammars with the fprintf function. All right. So that is the little different with the printf. So if you are interested in app printf, you can find in Google, and then you can complement the meaning in your written notes. For example, you can add the at the end of the printf function all by yourself. All right. So this lecture is not C programming lecture, but computer structure and system, right? So additionally, I will teach the basic and advanced C programming grammar with Linux. But our main part is the computer structure and system. So sometimes you should do the flipped learning all by yourself, such as Apple printf or error.h file finding. All right. Okay. We can go to the next example. All right. So how about the second example? This is very similar with the previous, the second representative C file, but we can't use the local variable x with the basic, the integer data type, right? So when the computer meets the second line of the main function, it allocates the specific memory with the name, memory name is x, and the x space can include only the integer data type, right? With the number 1 at the beginning time. But in the child process, the child process can increase the local variable x from 1 to 2, right? So the x can be printed with number 2 in the child process after fork, right? However, in the parent process, the local variable x can be decreased with 0 from 1 to 0, right? So the bottom line is for the parent process, right? So parent process can print the local variable x with the variable 0, right? So when you compare the previous C file with this, you can flexibly add the local variables, and you can check the change or the possible cases with the local variable x. So if I consider this example for your midterm test, I will ask, please add your own local variable y, and then please the increase with the about the 2 times or 3 times or just 10 in the child process, and in case of the parent process, you should decrease about 2 times or 3 times or 5 or 10, and then you can check in your Linux for the correct print the result. All right, so please compare and understand the each C program examples all by yourself for your exercise part of a midterm test. All right, so please consider the user-defined capital F fork function as well as these header files on top of this the third C program on top of the main functions, right? So and then you can execute the this source code in your Linux with your ID, and you can type and you can check result, and you can take folder, and then you can paste all your exercise traces in your Word file for yourself, and then you can submit your Word file for including your exercises on top of Linux and your written note writing. All right, and then I can check your diligence, the eagerness and traces per each my video of their each week. All right. Okay. And then we can go to the next the example. As you can see on the screen, a computer can't try to understand the first line of the main function first, and immediately the computer meets the capital F fork function. So the main function can fork, right? The copies the original codes for the child process in the separated memory space, right? So, for example, I can copy this code for the child process, for example, right? So this is for the parent process, and this is source code for child process. But different thing, parent process already executed fork, the first fork function process, right? So at that time, child was copied about this part only, right? Because parents already executed the first line of the capital F fork function, right? So the parent process on the bottom line executes the first fork function, right? So child has only the copied source codes with the second capital F fork function, right? So the child process also try to execute the second, the capital F fork function. So it can be copied to the separated the memory space. However, the third one has only two lines, right? So the hello can be printed with this location, and the first child can print hello too, right? And exit, and the parent original process can print, right? And then execute. So in the summary part, I will summarize again. Okay, in the parent process, execute the first line of the capital F fork function here, right? So the child can be copied here, right? And in the first child process, try to fork for the another child process here. So printf and exit can be executed. And then in the first child process can print and execute it, all right? And in the parent process can go to the next line after finishing first fork, right? So in the okay, all right, and then in the second fork function, parents can make the another child process, all right? So the in the separated memory places, can't, can't execute the hello printf and execute it. All right. Okay. So it is related with this part, and these can be related with this part and this part. All right. Okay. So that can be representative of the midterm test. So please understand the number of the capital F functions all by yourself, and then you can draw the process graph, that is process graph for the nested fork. All right, and you can compare original source code with the child process, the remaining parts of the original codes, and then you can check the successful results in Linux with your own ID. All right, and please study the first example, second, and third one for yourself, and you should prepare for midterm tests according to the number of the fork function 1, 2, 3. All right, and please write down the process graphs according to the number 1, 2, 3, and then fully understand each problems, and please exercise on top of Linux with your own idea about yourself. And do not hesitate to ask anything with KakaoTalk, SMS, and email, all right? And you should do the quiz for yourself, so that can be representative for the midterm test, all right? So, from the first week and this video, that can be content for the midterm test coverage, all right? So please review and repeatedly check your written notes, my slides, video, as well as your Word file, and then please prepare for the theory part as well as exercise with the C program language for your midterm test. All right. Okay. Thank you for listening. See you next video after midterm test. All right. Thank you. Bye bye.